Alright, this lesson's over compound inequalities. There are two different types. You've got your conjunction and your disjunction. So a conjunction is a compound statement that uses the word and. Okay, so let's take a look at that. Okay, there are basically three different notations we're going to use. So we'll start out with the inequality notation. Okay, so you'll see x is greater than or equal to -3 and x is less than 2. Okay, there's another way that you can write these, and it's as like a complete compound statement. Alright, so I'll show you what that looks like. Since -3 is less than x and x is less than 2, -3 is the smallest thing, so we write that on the left. Okay, it's less than or equal to x, and x is less than 2. So it's kind of like you flip this one on the left around, and then the x's in the middle, you just get rid of one of them and you only have a single x. Okay, this is the way we'll end up writing these more often than not. Okay, the way you see those on a graph, let's say you have -3, 2, 1, here's 0, 1, 2. Alright, whenever you have equal to, that's a closed circle. Okay, we learned that in our last lesson. Okay, not equal to, that's your open circle. And then x is in the middle, that represents the shaded part, so we shade in the middle. Any of those numbers could be x. Alright, then we've already practiced the interval notation in the past. Okay, that's -3, 2. Okay, with a square bracket going with a closed circle and a parentheses going with an open circle. Second type is a disjunction. This is a compound statement using the word or. Alright, so that looks like this. Okay, x is less than -3 or x is greater than 2. Now there is no secondary notation like there was over here. This is the only way to write it when it's a disjunction. Okay, so let's look at the graph. Do -3, 2, 1, 0, 1, 2. Circles will be exactly the same as they were on the other side. Closed circle here, open circle here. Except this time x is less than or equal to -3. So less than, we're going to go to the left. This one x is greater than 2, so greater than goes to the right. Alright, so you'll see that they diverge, they go away from each other. Whereas this one over here, they converge, okay, and they overlap. And we shade the overlapping part. Okay, interval notation. Okay, this is going to be a little bit new because we have two separate sets. Alright, so still start from the left. That's going to be our -infinity with a parentheses, comma, up to -3. And then with a bracket for the closed circle. And then over here we're going to have a parentheses and a 2. And arrow to the right goes up to +infinity. But somehow we have to join these together. Up here we use the word or. We don't use the word or for this. We use a U, like that. Alright, this stands for unioned with. Because if our solution occurs in either one of these sets, either or, okay, then it counts as a good answer. Alright, so let's practice solving some compound inequalities, pretty much just like solving an equation, except you have two separate parts, and they're separated by this word. Alright, so I'm just going to kind of make a little track there to show you we have two separate equations. Okay, then remember on the equations we draw our line down our sign so that we don't forget when we're switching sides to do the opposite, things like that. Alright, so I need to get my numbers away from x, so I'm going to add 5 here. That gives me x is less than 3. And over here we're going to draw our line, divide by -2. Alright, so this is unavoidable. We have to remember that when we divide by a negative, we're going to have to flip that sign over. So it's actually going to be greater than or equal to. And that'll be x is greater than or equal to +5. Less than 3 or greater than or equal to 5. Okay, we're going to both draw out our number line and write our answer in interval notation. Alright, so here's our number line. Remember, when you're writing down your points, I want to see 0. And then this one has 2 values I want to see on there. So 1, 2, 3, 4, 5. Alright, so we're going to have a closed circle on 5 because it's equal to, open circle on 3. And we're going to be less than 3, so that goes this direction. And greater than 5, that goes this direction. Alright, I really should be better about writing out our solution. X is less than 3, or x is greater than or equal to 5. Okay, that'd be a proper inequality way to write out your solution. Okay, you're going to be asked to graph it, so there's what the graph looks like. And then I'm asking you to also interval notation. Negative infinity to 3, parentheses, remember your u from the last page, bracket 5 to positive infinity. Alright, so be able to do all 3 of those. Alright, let's try an AND problem. Okay, it works the exact same way, so I'm going to draw our little railroad tracks here so we separate our 2 equations. And then we're going to draw our line down our equal sign. So over here I need to subtract 9, get my numbers on the other side. Negative 12r greater than or equal to negative 108. And then we'll divide by negative 12. So here it is again. We're dividing by a negative. We're going to have to flip our sign over. So now it's going to be less than or equal to. And over here we're dividing by negative 12. 108 divided by 12 is 9. Okay, over here we're going to do the same thing. So we're going to add 4. And that gives me negative 2r less than negative 8. And we're going to divide by negative 2. Here it is again. Ding, ding, ding. Anytime you're dividing by a negative, you want to flip that sign. So now it's greater than positive 4. Alright, so notice we can leave our answer like this. R is less than or equal to 9 and R is greater than 4. But that's not the most efficient way to write your answer. Most efficiently, you write the smallest number first, 4. And you say 4 is less than R, and R is less than or equal to 9. And that's the best way to write our AND problem answers. Okay, let's draw out our number line. Okay, I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, open circle on 4, closed circle on 9, and problem should be shaded in the middle where our variable is located. Okay, last step, interval notation, parentheses 4, comma, 9, bracket. Alright, let's take a look at one more. Alright, what you'll notice about this one's a little different is that it's already written in the good form that we wanted in. Okay, but that kind of poses a problem for solving it because we don't have 2 separate equations. Now you could write it out separately. Okay, if we took this equation and wrote that kind of out to the side, and then we took this equation and wrote that out to the side over here. Okay, but that's kind of more work than I think is necessary. So what I'm going to suggest us doing, draw lines down both of these. We're going to solve them both at the same time. Okay, so our goal is to get n in the middle by itself. Okay, we know that from looking at our past problems, that's kind of what we expect to have. Okay, so let's work on getting n by itself. So first thing I need to do is add 12. Whatever you do to the inside, you do to both of the outsides. Alright, it keeps everything balanced. So over here that gives us negative 21 less than or equal to negative 7n less than negative 14. Okay, next we need to divide by negative 7. Same thing here, same thing here. That gives me positive 3. I'm dividing by a negative, so I need to flip my sign over. Greater than or equal to n. Again, dividing by a negative, so flip your sign over. Greater than 2. Alright, now problems are never written this way. The answers will never be that way. They will always be the smallest number on the left and the biggest number on the right. So what you need to do is just kind of flip this whole thing around. So 2 is less than n is less than or equal to 3. And that's the proper way to write your answer in inequality form. Alright, your graph. We've got 0, 1, 2, and 3. We've got an open circle on 2, a closed circle on 3, and we're shading right there in the middle. Last but not least is interval notation, parentheses 2, comma, 3, bracket. Alright, that's compound inequalities.